Hi there, everybody. My name is Joe, and I'm a PhD student here in the Barley Lab. One part of my project, and what I'm going to talk about here today, is understanding the difference between speed of hydration, dormancy, and pre-harvest sprout, and how all three of these traits work together to breed better barley. Initially, we grew this population to dissect and show that speed of hydration and dormancy are two different traits and not the same thing. But then in 2019, we received an 1.5 inches of rain right as this trial was ready to be harvested, and that resulted in some severe pre-harvest sprout damage. So we decided to add that measurement to this population, and it's resulted in a pretty interesting story. Let's talk about pre-harvest sprout first. Pre-harvest sprout is simply defined as the untimely germination of barley grain. It can be as severe as germination of the roots or shoots on the seed heads, or you can see no visible damage whatsoever. Now, the most common metric to measure this is falling number, but for the size of this particular population, that was unrealistic. So we did some reading and found that the more alpha amylase that is present in the grain, the more sprout damage has occurred. Now, the best defense against pre-harvest sprout is dormancy. And for that, we'll go into the lab to look and see how we measure dormancy. All right, now that we've all made it to the lab, let's talk about dormancy. So dormancy is defined as a grain's ability to not germinate. So less dormant lines could germinate right away on the seed head, leading to lots of pre-harvest sprouting, or more dormant lines could take up to 2 months to germinate and we wouldn't see any pre-harvest sprouting. So how do we measure when dormancy is broken? We take 100 seeds, we add 4 mils of water, and then we place the sample in our germination chamber. From there, we check the samples every 24, 48, and 72 hours to see which lines have germinated. Once 95% of the seeds in a germination test have germinated, we consider that line to have broken dormancy. We have to check this every single week to determine approximately how many days after harvest it takes for lines to break dormancy. So let's talk about the pros and cons of too much dormancy versus not enough. Now, growers want plenty of dormancy so that they can prevent pre-harvest sprouting, but have just enough so that for winter crops they could immediately turn around and plant them. Versus maltsters, they want little to no dormancy because they can't start their malting process until dormancy has broken. So, as you can figure, it's kind of a balancing act of finding that sweet spot of just the right amount of dormancy. And that is where markers and genetic selection come in. These can allow us to be a little more precise with dialing in breeding, the proper amount of dormancy.
So the last trait I want to talk with you today about is speed of hydration. So speed of hydration is how fast the endosperm hydrates during the steeping process. The way this process works here is water comes in on the right here through the embryo. It follows the path of these red arrows and slowly hydrates the endosperm. The more hydrated the endosperm is, the more modified the grain can be. And this is a slow process that takes about 48 hours. So by improving the rate at which this hydrates, not only do we ensure better malt quality, but we could even potentially reduce the amount of time that you would need for some lines to steep. The other important thing to note about this is that the current belief is dormancy and speed of hydration were the same trait. But from this mapping population that I've been working with, we've found that these are two genetically different traits. So you can have dormant lines that are fast or slow to hydrate, and non-dormant lines that are fast or slow to hydrate. We've seen, at least from this population, is we can have fast hydrating lines with some dormancy and low pre-harvest sprout damage. This will make the growers happy because they don't have to worry about untimely rains damaging their grain, but it'll also make the maltsters happy because they don't have to wait too long for dormancy to be broken, and this faster hydration could lead to more efficient malting regimes and overall better malt quality.